Okay, for the last question, which is question number 15, consider a parallel plate capacitor with a capacitance C2 microfarad, battery voltage 12 volt. Okay, the first question they want you to find the charge stored in the capacitor. Once your Q, okay, and then kata, let's say if they put dielectric materials, find the charge on the capacitor. Q, so ada before and after, so I put that Q not, and Q is after to differentiate between the charges. And then they want to find the charge capacitor is isolated. Okay, then explain what will happen to the charge and the voltage on the capacitor. And lastly, they ask you to compare with the energy. Compare the energy of before and after with and without dielectric materials. So this question is about dielectric materials. No? Okay, I already draw it for you. Okay, this is the diagram. So this one before inserted any dielectric materials. First question, they want to find charge stored in the capacitor. So this one is straightforward lah. You can use C equals to Q over V. So Q is equals to CV. From C equals to Q over V, you can write down Q equals to CV. Okay, I just want to differentiate between previous and after, so I put here it's not. You can put C not as well. So this one doesn't mean peak, it just mean initial. This is V terminal, so it will be 2 micron multiplied with 12. So 24 times 10 negative 6 coulomb. And then dia kata now insert a dielectric with dielectric constant epsilon r. Find the charge on the capacitor. So question B, now they input the dielectric materials lah. So previously it's just an air. Okay. Now if you put dielectric materials, so obviously your capacitance will increase by a factor of 2.5. So if you guys still remember epsilon r, you can relate with C over C. Okay, and then remember only for E and V is the not above, kat atas ni, tapi yang lain semua dekat bawah. So like this lah. So your new capacitance, you will get epsilon r multiplied by C naught. So just a factor of you have to multiply with epsilon r. So epsilon r is equals to 2.5. So 2.5 multiplied with initially it is 2 times 10 into 6. So got 5. Yeah, 5. So this would be your capacitance with dielectric. So just put it here so that you don't get confused with dielectric material. But the question actually want you to find the charge, right? So once you find the capacitance, C equals to Q over V. Okay, V is still V terminal. So Q is equals to CVT. So it will be 5 times 10 negative 6. And voltage is 12. 12 times 5 is 60. So charge equal to 60 times 10 negative 6 coulomb. Okay, or you can write 6 times 10 negative 5 coulomb, same answer. Okay, and then the next part says that the charge capacitor with dielectric is isolated by disconnecting it from the battery. So there's no battery, and then keeping the capacitor isolated. Explain what will happen to the charge and voltage on the capacitor. So basically, you just remove the battery there. So initially, before it was removed, before the battery was removed, you have a capacitor with dielectric material. So the capacitance here is actually 5 times 10 negative 6. I forgot to put farad there. Oops. Okay, so this one is actually 5 times 10 negative 6. I just redraw the circuit and everything. So it's C not actually. Okay, what is the question again? Explain what will happen to the charge and voltage. Okay, so once it is fully charged, the charge will remain constant lah. Okay, example here, I can calculate. Okay, just before the dry cell being removed, so V is equals to, initially C equals to Q over V, right? So the charge here, wait, we already calculate this one, right? So the charge from previous answer, Q is equal to 60 times 10 negative 6. Since there is no power supply, this value will become constant. Charge is constant because it couldn't move anywhere else, so it just remain over there. So charge in the circuit remains constant. And then about the voltage, okay, I think I have to explain better. So it says here the dielectric material is removed as well. So not only the battery is removed, the dielectric also being removed. So initially it's like that, and then it becomes something like this. Copy everything. Okay, so if it was being removed, then the capacitance turns back to the original one. 2 times 10 negatives, is it 2? Yes, 2. So it becomes C naught again. Okay, when it was being removed, the charge remained the same again because the charge couldn't go anywhere else. Okay, over here the total charge Q will remain the same, but the difference will be the voltage because now the capacitance changes. So you can calculate a new voltage. C equals to Q over V. So this one is basically V equals to Q over C. I need to use C naught because now we are talking about without the dielectric material, but the charge is from the previous one. 60 divided by 2, I got 30 volt. Okay, and then the last question actually say explain quantitatively what will happen to the energy stored in the capacitor when the dielectric is removed from the isolated capacitor. So they want to compare before and after dielectric material is removed. And then quantitatively, basically they ask you to calculate. So with dielectric, I can use U equals to half CV square. This is my favorite equation. So the C with dielectric materials is 5. Okay, and then the V is actually equals to 12. That was previous, This come from the previous one. So 6 times 5, I got 30. There. Oh, I forgot to take the square, so don't forget to put square over here. Then calculate again. 3.6 times 10 negative 4. Okay, so basically this one with the dielectric materials, okay, because it is fully charged, even though the voltage power supply being was removed, so this one no power supply, but still because this one is fully charged at this moment, so you get voltage from the previous one, which is basically this one, and that's why we use 12 volt. Okay, but then once you remove the dielectric materials, the charge will remain constant, but the C returns back to the initial one. As a result, the voltage will be different. So without dielectric materials, so your U, you still use the same formula. except that you use C naught and you have to use V when the dielectric material is being removed. So it will be, let's see, not 2 times 10 negative 6, and then multiply with 60, sorry, not 60, 30 volt over here. 30. So U is equals to, again, don't forget to put square over there, 9 times 10 negative 4. Okay, as a conclusion, I can write that the energy increase. Dielectric material remove. Okay, and then don't forget to put the unit, which is joule and joule. Okay, thank you everyone.